I hope everyone's doing well. I'm Mr. Ish. Thank you for joining me for this video where we're looking at an interesting mechanism with regards to nitriles. What is a nitrile? Look right here. That's what you're looking at, or C triple bond N. This right here is your nitrile functionality. Remember always this, nitrogen is more electronegative than carbon, hence you have a dipole moment in the direction of nitrogen. You have a partial positive carbon, you have a partial negative nitrogen, hence the carbon can serve as an electrophilic site, an attack of an electrophile, and the nitrogen can act here as a Lewis base. Before we look at this mechanism, consider these two continuums, or you can call them lineages. If you're looking here at a water molecule, it can be converted into an alcohol, which can be converted into a carboxylic acid, as you can see right over here. Consider also this, you have ammonia over here, NH3, you can convert it into an amine or NH2, then you can also convert this into a nitrile, or you can do either or, back and forth, and then you can convert both of these into an amide, and then you're looking right over here at a generation of amide. The amide represents the end of both of these lineages. In all instances, if you're comparing an ammonia or anything which is a nitrogen versus anything which looks like a oxygen in terms of Lewis bases, the nitrogen is always a superior Lewis base than an oxygen. What is a Lewis base? Anything which is an electron pair donor is a Lewis base. Why is nitrogen a better Lewis base than an oxygen? Because it is less electronegative than oxygen, therefore it can give up its electrons, or it can donate its electrons easier than an oxygen which is more electronegative. Let's look over here at our mechanism. With regards to the nitrile and the mechanism, we're looking at everything in an acid environment, acid and water. If I'm looking at this nitrile and it finds a proton, you know a proton has no electron. A proton is basically one proton, that's what it is, and 0 electrons. Hence, you have that a Lewis base, or an atom which is a Lewis base, can seek it out and attack it. So what happens here is you have the addition of a proton to your nitrile. It's called a protonation, and you will have this develop because the nitrogen has donated, or it is sharing its electrons in the generation of this bond. It becomes charge deficient. It had excess, now it's become charge deficient, and that's what you have. Always remember, your carbon is partial positive. It serves as a site for a nucleophile, which here you can view as a Lewis base. Now we're looking at water behave as a Lewis base. It can attack this by means of these two electrons you see over here, and it can generate a bond. It will use two of its electrons to generate a oxygen-carbon bond, and what you'll see is this will happen. You will have a shuffling of electrons in the triple bond. A single of this triplex will break off and return back two of its electrons to nitrogen. You will have a double bond generate here. You've generated two electrons from the breaking of that one single bond. You have everything else, and you have your water molecule over here. Because it has used two of its electrons, it's sharing with the bond formation. It is now charge deficient, and you generate a positive charge over there. That's what you have. Think back to what I said at the very beginning. In all instances, the Lewis base nitrogen is superior to a Lewis base oxygen, and that's what you will see over here. Because of its Lewis base characteristics, look what will happen. I'm just moving these electrons for the demonstration purposes over here. This nitrogen will act as a Lewis base. It will snatch this hydrogen, and the bond, the two electrons of this bond will go back into oxygen. And what will happen is this: you have everything else which is being demonstrated as this, and you have that hydrogen come over here, and you have a return of the charge deficiency to nitrogen. It has stolen the hydrogen by using its two electrons as a Lewis base. The bond, two electrons have returned back to oxygen. You have this, the return of the two electrons from this bond back to oxygen. And now where do we go from here? What you will have is the two electrons of this oxygen will generate a bond with the oxygen carbon, a double bond, and you will have the breakage of this and the return of two electrons from this double bond, the single of this duplex, to nitrogen, and you'll see this happen. You have carbon, you have now a carbon nitrogen single bond, two electrons coming here, you have your hydrogen, you have a hydrogen. As you see, the single of this duplex has generated two electrons for the nitrogen. You have developed here a carbonyl functionality, and the hydrogen is still attached. Because oxygen has lost two of its electrons to generate this double bond, the single of this double bond, you have now a charge deficient oxygen. And now where do we go from here? It's basically our last step. I have a water here, I have an acid here. You have an acid here, you have to regenerate your acid. How will you regenerate it? You are looking here at a water molecule which is just floating around in the reaction. It will act as a Lewis base, steal this hydrogen, and the 2 electrons of this bond will return back to oxygen to fulfill the charge deficiency, the carbonyl functional group in its true formal form, and you'll develop here hydronium. And what the end result is this: you're looking at a carbonyl oxygen develop as this, you can see, and then you have a NH2, and we've developed here an amide plus this water molecule we protonated to develop here hydronium ion, and you've regenerated your acid. The reaction, as you see here, in the presence of water and acid of this nitrile generates an amide. Hence I showed you that continuum. You can start with water and alcohols, and you can start with amines, and you can go through a continuum and generate amides from both of those different lineages. And this is what we're looking here at, a generation of an amide by the mechanism you see. Acid, and the acid is regenerated, and usually the acid is always present in the mixture in the form of a hydronium. This right here is a very short-acting species. This right here is not as short-acting species, and most of the acid is in the form of a hydronium ion. And that right there brings us to the end of this video.